This is lesson 131 and 132. We are talking about attributes and characters of shapes. Okay, when we want to talk about shapes, we can talk about them using our words. It's important to know some vocabulary, but it's also helpful to have markings or notation that we use as well. So we are going to fill out this shapes toolkit here. That's going to be helpful to us. Let's talk about some notation real quick, okay? When we have two sides that are the same length, so we've got this side and this side, they are the same length, we are going to use tick marks to show that they are the same length, okay? If we have another set of sides that is the same length, we can use tick marks again, but we don't want to use a single tick mark because that would make it look like all of those sides have the same length. So instead, we're going to use two tick marks. So it should be pretty obvious which sides have the same length as each other. Okay? Then, if we have lines that are parallel, a reminder, parallel means that they'll never touch. So two parallel lines like that. To show that we have two parallel lines, like here and here, we are going to use arrows. Okay? So those two lines are parallel. And just like we did with lines that have the same size or length, if we have another set, we're going to use two arrows. Okay? And then the other marking on this shape you should be familiar with is the right angle. Okay? Right angle, which also means that the two lines that make up the right angle, we call these perpendicular lines. We will talk about that more in future lessons, but it's a good vocab word to know. Two lines that make a right angle are perpendicular lines. I'm going to go ahead and fill out this shapes toolkit, so that will appear for you in just a second here. All right, here is the shapes toolkit filled out with the same markings that we just talked about. There's one extra marking that I want to point out that you will see in some of these shapes down here. Okay, we have these little loops on the angles. Okay, they are not the squares that we see in a right angle, okay, but they mean that they have the same angle. Okay, so in a regular pentagon, all of these angles are the same measure. And same with the regular hexagon. All of these angles are the same measure. Moving on to Venn diagrams. Here's how a Venn diagram works. Okay, one of your circles is about one thing. Another circle is about another thing that is different from the first. But then in between here where they overlap, that is about both of these things. Okay, so they show us a cute little thing here. If the yellow circle is about Venn and the green circle is about diagram, then in between is what they share, Venn diagram, both of them. Okay, so CPM eTools, that will be an activity that you do in class. Okay, key concepts, again, filling those out on your own, but let's move on to check your understanding. Okay, we're going to fill out this Venn diagram given these statements over here. So Venn diagram number 1, this will be all the people that study a lot for class in this circle. Okay, Venn diagram number 2 will be people that have long hair. Okay, so the middle will be people that study for class and have long hair. Okay, so let's fill this out. So Carol says she rarely studies, but she enjoys braiding her long hair. Okay, so because she doesn't study, she can't be anywhere in this circle. She has to be just where the long hair is. So that is where Carol is going to be, in the long hair circle. Now Bob never does his homework and he has a crew cut. So Bob, he doesn't study and he doesn't have long hair. So Bob doesn't belong anywhere. He's just going to be floating outside of the circles. And then Pedro loves joining after-school study teams to prepare for tests, and he likes being bald. Okay, so we're going to have to put Pedro over here because he does not have long hair, but he does like studying. Okay, so we don't have anyone that both has long hair and loves to study. So that center overlapping area is empty. Okay, these shapes have been sorted into two groups. We've got group number 1 and group number 2. We have to figure out how they were sorted. Okay, so the first thing that catches my eye is that all of these shapes have right angles in them. And based off our shape toolkit up here, we know that these two shapes don't have any right angles, okay? So these two shapes could have been sorted out by right angles. That's the symbol for angles, right? And no right angles. Okay. There could be more ways they were sorted, but that's an obvious one. We're going to select the shapes that have at least 2 pairs of parallel sides. Right? So reminder, parallel sides are the ones that look like they will never, ever touch. Okay? And then we mark them with parallel side markings, which is the arrows. Okay? So this first shape does not have any parallel sides, nothing there. B, a rectangle, has 2 sets of parallel sides, so we're going to make sure to mark those with arrows. C, this triangle does not have any parallel sides. Neither does this hexagon. But this quadrilateral down here, just like a rectangle, does have 2 pairs of parallel sides. On to medium. We are going to try and determine how these were sorted, what circle has what attributes. Okay, it looks like every shape has a set of sides that are the same length, at least one set. Okay, maybe they have more, but they have at least one set that is equal length. Okay, so they have a pair of sides with equal length. And over in circle 1, those shapes don't have equal length, but the middle, we have to make sure those have equal length, and they do. Okay, so then the left side over here, okay, maybe this side is all triangles, because the middle shapes are triangles that have equal sides. So that looks like a good designation for each circle. Okay, where would a regular hexagon fit? Okay, well, a hexagon is not a triangle, so it can't be in circle 1, but a hexagon does have sides with equal length. So we could draw a hexagon over here. Regular hexagon would fit in circle number 2. And then where would the trapezoid fit? If we go back to our circle toolkit and find trapezoid, a trapezoid is not a triangle, and it has, it does not necessarily have any equal sides. Okay, it might look like it in this picture, but it doesn't necessarily have to have a pair of equal sides. So the trapezoid is going to fit nowhere outside the Venn diagram. Maybe just trapezoid out here somewhere. Okay, we're going to select properties for what each shape has. Let's start with a right triangle. Does it have a right angle? Yes, it's got the word right in it. Does it have perpendicular lines? Well, if it's a right triangle, that means it makes a right angle. And we talked about before how perpendicular means that those lines make a right angle. So yes, that is true. However, a right triangle does not have parallel lines, so we're going to leave that blank. All right, moving on to a rhombus. Let's look at our shapes diagram to remind ourselves what a rhombus is. Let's see if we can find it. Rhombus, rhombus, rhombus. Here it is. Okay, so the only thing we know about a rhombus is that it has all sides of equal length. Oops, I forgot to mark that it actually does have parallel sides. I missed that. Okay. So let's go down. Does a rhombus have a right angle? No, it does not. Does it have perpendicular lines? No, it does not. But it does have parallel lines. We can mark that one. And then a rectangle, I think that's going to be all three. It does have right angles. It has perpendicular lines and parallel lines. Okay. The two groups that we have here, okay, this one I was about to say might be right angles, but this shape over here has a right angle, so it can't be that. These have four sides over here. These also have four sides over here, okay. Let's come back to that one. We're going to move on to spicy, okay. This is actually the same Venn diagram that we did up here. Okay, so I'm going to ignore that one. And then Sandy has a square, equilateral, triangle, rhombus, and rectangular hexagon in a bucket. Robert has a scalene, triangle, kite, isosceles, trapezoid, non-special quadrilateral, and obtuse isosceles triangle in his bucket. So Sandy will randomly select a shape, and Robert will randomly select a shape. Okay. Who has the greater probability of selecting a quadrilateral? Well, let's take a look at how many quadrilaterals Sandy has. Quadrilateral simply means a shape with four sides. So Sandy has a square, that's a quadrilateral. A rhombus is a quadrilateral, and that is all. Robert has a kite, a trapezoid, a non-special quadrilateral. So this one is going to Robert because he has three shapes that are quadrilaterals. Okay. Who has a greater probability of selecting an equilateral shape? Okay, let's see how many Sandy has. Sandy has equilateral triangle. Now, regular is another word for equilateral. Okay, regular just means that all the sides are the same shape, or all the sides are the same length. Okay, so we can count that as an equilateral. And then Robert has, let's see if a kite is equilateral. It is not. Okay, a kite does not have all the same sides. So Robert has none, which means this one is going to go to Sandy. And then what is more likely to happen? Sandy selecting a shape with at least two sides that are parallel. Okay, so at least two sides that are parallel. Or Robert selecting a shape with at least two sides that are equal. Okay, so equal sides, equal. Let's see. Sandy, let's see how many shapes have parallel sides. A square does. A rhombus, let's just double check. Yes, a rhombus has parallel sides. Rhombus. That is all. So she has two. Let's see how many of Robert's shapes have equal sides. Okay, scalene triangle. Scalene means none of the sides are the same, so it's not going to be that. A kite has a set of equal sides. And I think that is all. Okay, so that means that Sandy is going to win that one as well. Okay.